So if you've got a uniform distribution and it's between 0 and 7, if it's less than 0 or more than 7, it's automatically 0, correct?
Oh, yeah, so some of the questions are outside. So yeah, if you had something from 0 to 7, and it said, what's the probability that x is greater than 7?
Right.
Well, it's this 0% chance, right? So sort of like if I said, what's the probability you're walking down the street and you run into a 20-foot tall person? 0. There's been no observation of a 20-foot tall person, so there are none of them. So there's a 0%. It's outside of the realm of where the values exist. So they give you a uniform distribution from 0 to 7, and even to go even deeper than that, something I didn't talk about last time. So if I have a uniform distribution from 0 to 7, how tall would it be? 1/7. Because the whole thing has to have an area for it to be a valid probability distribution, right? Once I create that, once I make that happen, if I want to know any probability, it's the area of that. But so if I wanted, for example, from 2 to 3, what would the probability of something from 2 to 3 be?
1.
What's the width? 1 times the height. So it'd be a probability of 1/7. Okay, maybe. You guys kind of with me? All right. So what's the probability of exactly 3? That is a weird-ass question, right? So the first thing you ask me, what's the probability that it's greater than 7? That one's easy. What's the probability that I get something bigger than 7? 0. There's nothing out there, right? So that's nice. If the answer is the area, how much area does a line have? This is a geometric problem. So it's got no area, right? How wide is that? Not. What's the width? 0 times 1/7 is 0. So theoretically, the probability I get 3 is 0. And if you think about it, I really try to think about this. How many numbers are there from 0 to 7? Infinite freaking number, right? So the probability I get any single number, any actual single exact number, is basically 0. Do you guys kind of get that? Now, as a student, when I first learned that, I thought that can't actually be the right answer. Because if I add 0 up a lot, I get 0 still, right? And I'm supposed to, if I add up a bunch of things, I'm supposed to get, like, the probability from 2 to 3 was 1/7, and I can't get that if I add up 0 forever, right? Do you guys kind of see what I'm saying? I'm going a little bit beyond right now, but there's, infinity, good old infinity, right? There's an opposite process, and it leads to something called iota. Anybody ever heard of iota? Normally, if you've heard it, you say something like, your chances are iota, you got iota chances, or iota means the smallest positive number. So just like, go with me for a second. I know I'm going off of my math shit, but just go. Infinity is basically, if you think you have the biggest number, just double it. And then double that, and then double it. You guys with me? That's infinity, right? It's just that process of continuing to go. Iota is the reverse. If you think you got the smallest, give me the smallest positive number. Give me what you think it is. 0.00001. Okay, cut that in half. Now cut it in half again. Now cut it in half again. You see that you can keep going forever in that direction too. So iota is sort of like related to that 0 plus you see in the book. It's like not 0, but it's really close to 0. All right, I went off on a tangent there. I apologize, but oh well. I like this stuff, so I will do that every now and again. Anyway, so if they ask you what's the probability that x equals something, it's 0 because it's got no area. It's essentially 0. Now, if you put down iota, oh my god, that's so awesome. Right? Or 0 plus, I'll understand what you mean, right? It's not really 0, but it's just like the next closest thing to 0, which is a process. You can't even get there. You think you're there? Cut it in half. Oh shit, I wasn't there. Okay, maybe. Enough of that. That's a little bit above and beyond, but all right. Anything else from homework? Did I answer all that question? What was it? Did I get all of the parts?
Yeah,
whoever asked that? Yes. Okay. Anybody still need the z-score chart? This guy here. Oh. This is why I'm going to do the first thing we're going to do today, which is some practice on using this thing again. So here, let me give you guys a situation, and I want you to figure out the probability. So if you weren't here when we introduced this idea, some bad classes to miss, but we're going to do some quick review. So if I give you a normally distributed situation where the mean is, which got you up 87.2. Standard deviation, let's say, is 7.911. Going. And I ask you, let's say, what's the probability I pick something that is less than 90, or the probability I pick something that is between 80 and 95. Let's do those two problems. Now, if you weren't here, you might want to get together with somebody who was here, watch them work, or just wait. Good. it does feel like that. That's why I'm doing this.
Can't wait till next week and then know it's forever ago.
Yeah, next week we're out. A whole week to have stuff leak out your head.
And then I test the first day.
Yeah, Tuesday is a test. No, Thursday is a test. You ever had a teacher give you a test on Monday after spring break?
Yes.
They suck so bad. I had that myself also, and that was just evil. I'm like, good Lord, what happened to you in your life? I've had a relatively okay life, so I have no desire. You guys feel like I do take shit out on you, but I don't. I'm trying to get you through stats. It's not me to take a shit out on you. You don't want me to take shit out. All right, let me catch up to you guys. I recorded the whole thing, and that's awesome. It's pretty exciting. All right, so here's the picture that you desperately should draw. And before I can use this chart, what do I have to do? Yeah, this is a z-score chart, so I got to make these into z-scores. I'll do this one. Yay. And so it's going to be always my data point. This mean is always second. And I know the z-score should come out to be negative or positive.
Positive.
Because it's above the mean. So it's a little quick check so as you do your work to make sure that you've got things in the right place. No, Jeff, you can do it. There you go. So what's z for this one? 0.35. I guess it's 0.34 something or other.
No, it's 3539.
3539? Okay, so 35, I like it. And we routed to 2 places just because the chart goes to 2 places. That's a good reason. So this is 0.35. What does that mean? That's 0.35. What does that mean by itself? What does that mean?
0.35 away from this.
It's like a little more than a third of a step, right? Is that cool? Like 0.333? It's a little more than a third of a standard deviation above the mean. A full standard deviation above would have gotten me up to like 84, 85. Right? If I went a full step up, this is 1/3 of a step up. I only made it up to 90. Okay. So what can I do with this 0.35?
Look at her.
Yeah, so if I look up 0.35, this chart tells me, if I look up a z-score, the chart will tell me the area below it. If I'm using what kind of distribution? Normal, I like it. So the chart only works for normal. It's got a picture at the top of it telling you that. The picture even tells you what the chart does. You look up a z-score, I'll give you this blue area. It's telling you. So when I look up 0.35, let's see. 0.35, bam, there's 0.35. 0.35. I get 6368. And of course that is there. And the one thing I didn't do is I should have done what's this tell me? Yeah, so this is my area I want, and that's the area I got. So this probability is roughly 63.7, almost 64% chance. Is that cool?
Yeah.
Yes, yes, yes. All right, so there's always these 2 layers to stats. I mean, and on the East Coast at the college I used to work at, I was the assistant to the director of institutional research and planning. Was one of my hats I wore. So I got to do all the grunt work basically, which was enter all the data and do all the calculations. So as a math person, you just get totally into the formulas and the numbers and shit. But then we can certainly step back and go, all right, what did I just do? What does that mean? So that happens. So it's fine to get totally into the numbers, and then you got to step back and go, okay, what did I just figure out? What just happened? Whatever this represents, let's say this is a grade on a test, there's a 64% chance almost that somebody made less than a 90. I like it. I like it. So what's the difference with number 2 then? Same thing, except now I have... Yeah, so I still put the mean in the middle. 80 up to 95. So I want this area here. All right, Jeff. Sorry. And if I make those into z-scores, I can then look up the areas, and then you subtract. Don't subtract the z-scores because then you're just changing where you are. Z-scores tell you where you are. So what'd you get for the z-score for this guy? Negative 0.91?
Yeah.
And what about 95? Who is it?
0.99.
0.99? It's almost 1, Jeff. Yeah, because that would be...
It's like 0.98.
Okay, I got you. All right, I'm with you. So if you look up 0.99, 0.9, 9, 8389,
Yes.
and that's this whole area all the way down, theoretically forever.
Yeah.
So what do you got, Jeff? 8389. That's too much area. How much too much?
The 8.
By this much is too much. I want to stop here. So if I figure out what that area is, I can subtract it. So make sure that makes physical sense. You're not used to this, but you can actually make what you do make physical sense. It has to make physical sense. So to get this area, I take this giant area minus this little area. It leaves me the stuff in the middle. That only makes physical sense. So what do you get when you look up negative 0.91?
0.814.
1814?
Yeah.
Knock it. Be real careful. People get into the bad habit of thinking that the first thing they see is the 1. That's negative 0.90, and then that's negative 0.91. Remember that. That kind of sucks. So what's the answer then? It's going to be
0.6575.
I like it. So subtract these two things. 0.6575, yeah.
Yeah.
So about 66% chance almost that somebody would make between an 80 and a 95. Right, so pretty good odds there. Okay, maybe. And again, some of the problems in the book might seem very contrived. I try to make the problems on the test more real world, more, like airlines uses all the time. What happens sometimes when you go for a flight? What might happen if you're really unlucky? You'll get bumped because what did the airline do? I'm sorry, I missed something there. I guess there's a lot of answers to that. What was the answer, somebody?
He said he'd die.
That could be your standard answer to anything. If you walk out the door, what could happen? Well, you could die. This is true, even if you don't walk out the door. Oh, shit. All right, stop. All right, this is true. You could die. Or you could not die and die later and then have a whole movie out of it. But so I could get bumped. And why do I get bumped? Because the airlines did what? I'm sorry, let me catch up. They overbooked a flight. Now, why the hell would they do that? They want a full flight. So they know the statistics about the percentage of people that don't come after they've booked a flight. You guys still with me? They use that information to figure out, well, how many tickets should I oversell by and still keep it without having too many people give me too much bad PR. So if they do it too little, overall, if they keep doing that, they're going to lose money. They're not going to make as much money as they could have. If they do it too much, they're going to be in the news. They're going to have people saying, well, this airline bumped 20 of us. Screw them, right? Do you guys understand what I'm saying? So that's the type of thing that I like to give as a problem on a test. Something that explains something that happens to you in real life. Why are the doors as tall as they are? Because they can calculate the percentage of people that have to duck at a certain height, and they don't want to be too many, so they don't get too many complaints or people don't knock themselves unconscious if they're not paying attention. Yeah, I'll see you. That kind of thing happens. Okay. Cool. Let's do a couple more things with this. So that's the basics. This is what I call the classic z-score problem. This needs to become second nature to you. Because the next thing we're going to start doing is we're going to start tweaking this. Right? This is if I pick an individual person. What if I pick several people and I say, what's the probability that their average is less than 90? That changes things very slightly. We're going to talk about that today. So that's the kind of thing I could do to adjust this. Depending on what the situation is, I have to adjust the formula that I use. Well, let's do... hello. I guess that's the end of that round. Let's do one more here. Can you find the score to put you in P85? So let's do this one together, because this is one that still gives us some trouble. We just learned how to do some of this shit, so I understand that. You got to remember what P85 means, right? It's not some new workout thing. What was the other one? P90, right? P90X and all kind of stuff. What does P85 mean again, sorry? And what does that really, really mean? If you're in the 85th percentile, you...
85% of people below.
Good, you scored higher than 85% of people. So where would it be? Would it be
To the right.
to the right? Because it's got to have 85% below. What does the mean have below it? The mean cuts it in. So the mean has 50% below it. The mean is the median. It's P50. So P85 should be up here somewhere. I like it. Another way I could have said this so you'd come out to the same answer is I could have said the top 15%. The top 15% also means P85. 85% must be below you then. They mean the same thing. Let me stop there. All right. So what I'm looking for, where do I put 85 or something like 85? That's the area. And it's 0.85. This area is 0.85. Right, so I really want to make that point because people will put it there and they'll think it's a z-score and they'll look up the probability and they'll give me that. And I'm like, no. In fact, can somebody estimate for me what it should be? If the average was this and I want to be in the 85th percentile, if I made that score exactly, I would be in the 50th percentile, wouldn't I? Because I would have scored higher than 50. So if I want to be in 85th percentile, my grade better be at least higher than that, right? That's the least I could say. It's got to be higher than that.
Yeah, it's like 1.
So if you're giving me an answer like 0.1017, I'm like, holy shit, that's a pretty low score. Like, I can't give you a 0. Let me give you 0.1. All right. I'm sorry. Let me catch up to you guys. So what's the z-score that relates to this? Yeah, where are you looking? So that 0.85 is not a z-score. So you don't do like this. You don't say 0.85. No. Because I don't know what the z-score is. It's an area, and the areas are in the body of the chart. So 0.85, the closest I get to 0.85 looks to be
1.4.
this guy here, right? 8508. That's the closest I can get to 85%. And that, when we finally catch up to you guys, 1.04. I like it. So that's 1.04 as a z-score. So one thing I want you to realize, one reason why I like making you use this chart instead of just getting the areas from the calculator is you start to, without even realizing it, you start to get a feel for how this is distributed. So, what was this again? This was 1.04. We're not done with this problem, but real quick, if I think about it like this, if you start at negative 3.5, what area is below you? Start at negative 3.5, what area is below you? 0.0001, right? And I love the idea that as you move up, you start collecting more and more area below you, of course, right? That's what this chart represents. As I move from left to right on the chart, I start collecting more and more area behind me, and that's what this chart shows you. So you start to develop an instinctive feel for that, believe it or not, if you use this chart. Yeah.
Didn't you say you should use the closest one to what you're looking for?
Yes, I did.
So you use the 85.08, but the one below it, 84.8 or 0.8485, is closer by 3. Or
No.
0.003.
Where'd it go? There we go. So this is 8 away. You understand what I mean when I say that?
Oh, it should be 95. Okay.
And that is 15 away, yeah.
Yeah.
I like it. Okay, cool. It's okay. Trust me. Yeah, I make plenty of mistakes, so let me know when I do. But yeah, that one's closer. I like it. So remember, you can cut it in half. You can split the difference when it's pretty equal on both sides. When it's equally far away from both sides. If it's definitely closer on one side or the other, then you pick that one. So that was the one that's closer to it. I like it. Cool. It's not Price is Right. You can go over. All right. Now, what do I do? Is that the answer to the question? No, this is not a score. This is a z-score. It's not a raw score. It's not a grade on whatever this thing is. How do I convert that back into a raw score, to a physical something or other? Yeah, you use this little formula here. Because what does a z-score mean?
How far away from the mean
In-
standard deviation.
So yeah, so it's how many of these away from the mean your data point is. So that's, you can read that as a sentence. Because just to remind you guys, I'm going to ask that question on every single test, right? I think on the first test, I had a pretty large percentage of people get it wrong, so I'm hopeful someday. So I'm going to ask the same question again. So what do I know here? I know the mean, 87.2. I know the z-score, 1.04. And then the standard deviation, 7.91. So I really want this to make sense. If you go this many steps up from the mean, you're going to end up at the 85th percentile.
It's 95.423.
95.42. 43. Whoop. Yeah.
230.
23.
Yeah.
No, it's 2.7.
27.
That's, well, I
Screw
got
it.
4.23. There you go.
Are you good? Kareem? Are you good?
Yeah.
Okay, cool. I like it. When questions get answered before I ask. Okay, cool. I like it. So, let's talk about some new stuff then. Let me do this real quick while this is up here. I have this here for a couple reasons. Not because that picture is really enough. Let me see if this has got it. No. So see what they say. Look at all this stuff. Look at all this stuff. Standard deviations in there. So when you go to get a bone density test, and most of you guys are very far away from worrying about that, depending on what your health is. The score they give you is not the bone density. The score they give you is like a z-score. T-score, we're actually going to learn T-scores later, but they're basically z-scores that have been adjusted a little bit if we don't have a perfectly normal thing. Are you guys kind of with me? So that's in our future. So when you see T-score, you just think z-score. So if their z-score, if their score on this test was 2, that means their bone density is 2 standard deviations above the average, which seems like that would be a good score. You don't want a negative score, then that would be below, right? Depending on how they do this thing. Blah, 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 blah. Where's what I want to show? Blah, 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 blah. Oh, okay. So a negative value means you have thinner bones. So like I said, negative is bad, positive is good. I like it. I think that's all I wanted to show you here. Yeah, we have a handout coming up later that's got a bone density problem on it. And I just want this kind of like in the back of your mind that this is how it's actually done. Right? They do this this kind of work. Okay, so I can put him away for now. Alright, so what we're going to do, I got one of my most colorful handouts ever for this. We need to go from, like I just said a minute ago, we need to go from talking about individuals, because what do we normally study in statistics? We don't study individuals, we study samples, groups of people, right? So very often I'm interested in, if I wanted to test a claim, let's say that I claim that I do a workshop where I can increase your SAT score by 500 points, right, on average. Are you guys kind of with me? All right, and you've heard this kind of claim before. There's like Kaplan does this and whatever, if you're into that kind of thing, right? All right, and so to test this claim, I'm not going to look at a single person's results because a single person could do anything. I'm going to look at a group of people that go through my workshop and compare them to what? The general population of a general group of that size. What would a general group of that size be expected to do? And I want to see if my group did better. You guys semi with me? So we have to analyze the math of groups. We've so far only done math on individuals. I don't know if you've realized that. Every question we've asked has been pick one thing. Now, when we did probabilities, we can kind of directly do 2 cards, but even that's still 1 by 1 by 1, not a whole group at once, right? So we got to develop that math. So I'm going to start by talking really big idea, and then we're going to drill it down to really big time specifics, It's going to take me a while to talk about it. You guys are going to have to find a way through. Right? And at the end of it all, it's going to be one tiny little thing that we have to do to the equation. It's almost going to be like, holy shit, that was a lot to go through for that. But just to warn you, that's coming. So here's the big idea. I'm going to go back to my favorite example that we used earlier. Yes, ma'am.
What section is this?
7-1. Yeah. So there's only 2 sections we do in chapter 6. And we basically done them a few times over. So chapter 6 is in our rear view window. Chapter 7, we do 7-1, 7-3. To be honest, 7-1 and 7-3 are almost the same thing. One talks about the idea, and the other one says, and here's how you use it. You're like, okay. So like the same thing. So here we go. Do you guys remember we did this earlier? We did the ages of people in Florida. When we talked about chubby dude?
Yeah.
I like it. So let's say this is a possible distribution of ages in Florida. And so like I just said, I mean how did I create this, if I would have really done this, instead of just making potato shapes on a line, if I would have actually done the analysis, actually done the data collection, what would I have done to create this picture? I want to see if you guys are with me on this. Let's say that the mean is 40 or something. What would I have done to start creating this picture? Let's see if anybody understands what this picture means. What does this picture mean? Let's say that this is 72, and this is